So since we have established the fact that we need to have a forwarding protocol, that is internet protocol, to forward packets that may take different paths to reach the destination, and it's important for us to look at the envelope of this forwarding protocol, means internet protocol, means let's try to look at the header of IP datagram. And remember, before that we have talked about that an IP datagram, broadly speaking, has two parts. It has a header and data or payload field, and it's time to expand the header and see what are the different details or what are the different fields in the packet header and what's its utility. So first of all, the first field is called a version. It identifies the IP protocol version. It's a 4-bit field, and it is used to identify the protocol version, which is IP version 4 at the moment, because this IP datagram is of IP version 4. And this helps the router to decide how it will be dealing with the IP datagram of a specific IP protocol. And then we have next 4 bits for to identify the header length. So if a header length field is there, this means the header length is not fixed, right? So usually this header length is 20 bytes. This header length is of 20 bytes if I do not make use of this options field, right? So if I have if I'm using this options field, this means the header length can increase, but usually the header length is 20 bytes. And then we have this type of service field. Type of service field. I hope that you're familiar with this type of service field, as we have covered this in the previous lecture. This type of service field is basically, these are 8 bits, 1 byte, and first 6 bits, as you know, are used to identify these different classes of data, and last 2 bits are used for explicit congestion notifications. And then we have the length. Then we have next 16 bits to identify the total length of the IP datagram in bytes. So this includes both the header plus the data field, right? And then we have these 3 fields: 6-bit identifier that identifies the that differentiate a packet from the other using special identifier. And then we have 3 flag bits. So there are 3 flags. So we have DF flag, and then we have MF flag. DF stands for don't fragment, MF stands for more fragments, and 1 flag is result. And then we have this fragment offset field. These 3 fields are, so these 3 fields are used for fragmentation and reassembly, and I'll discuss these 3 fields in detail in a minute, right? So I'll leave it with a question mark. I'll try to cover it in the next couple of slides. And then we have this 8-bit. These 8 bits are to define TTL, time to live. Right. So this time to live is to ensure that a packet is not continuously circulating inside a network. So every time a router forwards a packet, it decrements the TTL value by 1. And if a router receives a packet with TTL value 0, it will discard this IP datagram and will send an ICMP message to the source machine telling that the packet has been, or the IP datagram has been discarded because its TTL value has expired. Okay. And then we have next 8 bits. These 8 bits are used to define which upper layer protocol to deliver the data placed inside the payload field, right? So, for example, if the value of this field is, for example, if I want to deliver it to TCP, the value is 6. If I want to deliver data to UDP, it's 17. And if it's, for example, Internet Control Message Protocol, the value is 1. So this field has its implementation similar to the port number, where the port number identifies which process to deliver the data at the application layer from the transport layer. And here, this field identifies the protocol to deliver the payload to, right? Either I'll be delivering the payload or the data in the data field of IP datagram to TCP or UDP or ICMP. And then we have 32-bit source IP address and 32-bit destination IP address. And here we have this options field, and in this options field we can use timestamps, we can record the path that is taken to reach destination, or we can list the routers that we need to visit in order to reach a specific destination. And this 16-bit, these are 16-bit internet checksum is for error detection, right? And then we have this payload field, and this payload field have a data of 65,535, right? So obviously this much amount of obviously this huge size of an IP datagram is not possible because at the data link layer, the maximum transmission unit does not support this much amount of payload field.